Hello, yeah, good day to you all. So, welcome to the ICT lesson online. The topic today is logic circuit. Notwithstanding, for you to be able to have ticket to this topic, you should have done your assignment on the chart, which is a sub topic from the spreadsheet. Also, you should get prepared for your drama that you are going to present in the course of taking the computer professionals. So let's get it started. Logic circuit. When you hear these two words, what normally comes to your mind? The two separate words. So, logic, as you know, that is an ability to reason. You might have been in a situation where somebody will tell you, "Oh, use your common sense." The person is trying to tell you to use logic. Because you have seen 8 and 8 does not mean your answer will be 88. If you use logic, you know that 8 and 8 or 8 plus 8 uh, should mean 16. So if you don't use logic, you might think it will be 88. You understand? So that is logic. Ability to reason to have a valid conclusion or a valid decision. Whereas circuit is connection, different connection that you have to have a particular result. So combining the two together is now having to for is a matter of or a situation whereby a particular device, in this case the computer, will reason to give a particular conclusion or a particular decision. So let's start with the objective. As you know, that will be for every class. Objective of this lesson, at the end of this lesson shouldn't last more than 30 minutes or thereabout. You should be able to describe the logic circuits. You should be able to explain and interpret logic gates. Don't worry about that. You get to know that very soon. Then, lastly, you should be able to construct some logic gates with their corresponding truth table. So let's get it started. Like I've said earlier, logic is the ability to reason to get a valid decision or a conclusion. For example, automatically anybody that gets to this juncture should know that if you are trekking, it's an opportunity for you to pass the zebra crossing. And if you are driving, that means you have to stop so that young people, youth students can pass. So that's a matter of logic in human being. So also, if you get to this kind of juncture, at this junction, some might go to the left, which is the past. I wouldn't know. But a normal, reasonable person who has a very good, a sound mind should go to the right, which is the future. But in this case, where you will go to will determine where you go to will be determined by your personality, by the way you, by your lifestyle, by the way you think, and the rest. For example, I don't think anybody will want to go to this country for now because there is work going on there. So your gate, your reason should tell you to navigate to another place. You can go to London. I know many people prefer London. It's a very good city. New York, nice city. Well, Beijing, Istanbul, yeah, they might be involved one way or the other in the current war that is going on, as well as Delhi. But as a matter of fact, the idea is that logic will tell you where to go to, what to do. So, as we have this thing in a human being, also we have in a computer. What we are seeing right now here is in a computer system. These are the things you see when you unscrew a computer system. So all these things will give you what they call computer logical operations. All these wires, they get connected together to form uh, the operations that you have. Those are the circuits. So whatever thing the computer is doing is because of the kind of reasoning that is being put in the computer. Then know that, of course, the computer can never work on its own. So it can only work based on what has been input into the computer. So what the human being input into the computer, what the person inputs will be the output. It is the input that will determine the output from the computer. So let's continue. Now the logic gates. Just know that this logic gate is characterized by two things. Number one is the logical symbols. Then the other one is the truth table. Please, I want you to repeat the two as I'm talking to you. The logical symbols and the truth table. The combination of the two constitute what they call the logic gate. So I would like to tell you that what you are seeing on your screen now is the truth table. Here you have four tables: one, two, three, four. So let's also show you the logic symbols. Here you are having six logic symbols: one, two, three, four, five, six. So these are the logic gate. When you are being asked to describe the logic gate, tell them about the truth table and the logical symbols. By that time you must have satisfied the examiner. So I want you to note something. Like I said earlier, in all these systems, there must be an input and an output. And in the truth table, truth table is binary. The meaning is that it is only 0 or 1. There are no three ways about it. There are just two things. It's either it is 0 or 1. It's either it is true or false. It's either it is yes or no. You cannot see 6, 7. So that is why all these things you see in the table, they are 0 or 0 and 1. So let's continue. As you can see, how many inputs do you have here in this kind of symbol? In this symbol, you only have one input, as far as I know, and you only have one output. In fact, as a matter of fact, all the gates are having one output, and also almost all of them are having two outputs, except just one gate, which we are going to talk about just now. So you can see there is input and there is output. In this case, there are inputs and there is an output. So let's get it started. These are the logical symbols. Let's look at the gates right now. Logic gates. There are 6 logic gates. Number 1, we have the AND gate. Please, I want you to repeat as I'm saying it. Number 2, the OR gate. Number 3, they call it popularly known as exclusive OR gate. Exclusive OR gate. Number 4, the NOT gate. Number 5, the NAND gate. Then the last one, the NOR gate. So let's look at it one by one. We are going to start with the NOT gate. And the reason for that is because of its uniqueness among other ones. It's unique in the sense that it has only one input and definitely one output. Unlike other gates, which all other gates have 2 inputs and definitely one output, but the NOT gate has 1 input and 1 output. As you can see, this is the NOT gate. The input is A and the output is B. So this is a symbol, whereas this is the table. So as the name implies, NOT, which means anything you have as the input, the output will be opposite. If the input is 1, the output will be 0, and vice versa. If the input is 0, the output is 1. So I would urge you, I will implore you not to be working as a NOT gate. If your parents should tell you do this, make sure you don't do the opposite. Don't be like a NOT gate, because a NOT gate you always do the opposite of what it is being told. So as I have said earlier, the truth table are always in binary. You can see, you cannot see any number here apart from 0 or and 1. Exactly. So that's the NOT gate. That's all about the NOT gate. When its input is 1, the output is 0. When the input is 0, the output will be 1, because it works in the opposite. The output works in the opposite way to the input. So let's look at another gate now. Yes, this is the AND gate. As you can see, unlike the NOT gate, and like all other gates, apart from the NOT gate, it has 2 inputs, then 1 output. Don't worry about this. Just look at the symbol. Now, coming to the truth table. The truth table might look difficult, but honestly, it's very simple. Let me just give you the concept. All the inputs are the same. They will test all the binary system, 0 and 0. Then the next one will be 0 and 1. Then the next one will be 1 and 0. And the last one will be 1 and 1. So the permutation for all the binary system. So that's the input. And they are the same in all the gates. Definitely except NOT, which has only 1 input. So now, what you are expected to focus on is the output, which is also simple. Just know for the AND gate, for you to have 1 or yes or true for the AND gate, it means the 2 inputs must be true. The 2 inputs must be 1, like you have here for the AND gate. That is how the AND gate reasons. If the two inputs are not one, definitely your output will be zero. That's why 0, 0, definitely you have 0. 0 and 1, it is 0 because it is AND gate. AND want to be double sure. This is like you can, just for the sake of your the memory, this is double sure. So for me to get 1, the two inputs must be 1, otherwise it will be 0. So that's all about the AND gate. You have seen the symbol for the AND gate. You have also seen the truth table for the AND gate. Let's go to the OR gate. Yes, just like the AND gate, it also has two inputs with only one output. Then, like I said earlier, the inputs are always the same. Testing the binary system 0001 1011. So what you just need to focus on is the output. Now, the OR gate, 0 and 0 input will definitely give you 0 output. Uh, you, you tell me to off it, you tell me to off it again, definitely the person will off it, even though it's reason like OR. So, in the case of OR, you don't need, OR does not need to double sure. Once one of the input is 1, OR will definitely give you 1. As the name implies, this or this. So, if anyone in this one also, in this column, the one is 1, the other one is 0, it gives you 1 because it's reason like an OR gate. Then if the two are now 1, definitely the output will give you 1. So that's how the OR gate, that is how it works. So let's look at another gate, NAND gate. You don't need to stress yourself really on this. Just know that the NAND gate is just the direct opposite of the AND gate. So let's quickly look at the AND gate. Let's go back. You can see the inputs are always the same, like I've said. So 000001, that's for the AND. Then look at the NAND. You see 1110, just the opposite of AND. So you don't really need to cram or memorize anything, just know the concept. So the same thing applies to the NOR gate. Like I've said, the inputs that will be they are always the same, 0001 1011. But the output, A nor B, NOR is just the negative of OR. So let's quickly look at OR. Okay, so 0111. So I've told you that the difference will be in the output. The inputs are the same, so it's 1000. So you can see. Then don't forget the application of this thing is it is used in making inverters and similar machines like that. So let's look at the last one, the exclusive OR. Don't worry about this. So this is symbol, this is the truth table. So just know that this is the concept. Exclusive OR will never give you 1. It will only give you 1 if the two inputs are unidentical. In other words, they are not identical. If the inputs are identical, like 0011, it will give you 0. So for the exclusive OR gate to give you 1, it means the inputs will be unidentical. Identical inputs, you can note this down or jot it somewhere. Identical inputs in an exclusive OR gate will give you 0. If not, or otherwise, it will give you 1. If they are not identical, definitely it will give you 1. So that is exclusive OR. Now, please try to identify the following gates. Know the possible gates they can fall into. For example, this first one definitely can never be a NOT gate because it has only, NOT gate has one input and this has two inputs. So this can definitely be AND gate. It can also be the NOT, the NAND. It can be the AND gate, the OR gate, and the what? Exclusive OR gate. So this can be any of the 3 gates. So likewise, this one too, of course, this one can be OR gate. One of the input is, this one cannot be an OR gate, and it can never be an AND gate. So it can be NAND. This one can be a NAND gate. So try to study all these things. This one definitely you should be able to know that 1 and 1 input is giving you 1. Definitely it is sure that this is a typical AND gate. Try to study them, and I'm very sure when you study all these things, it will be very simple. Yeah, the last stage, these assignments. Make sure you do it so that you can have access or ticket to the next class. Sketch the logic symbol for 3 logic gates. I don't want to stress you with the tables, but you can also add the table as well, because definitely the gate is the combination of the symbols and the truth table. So catch you in the next class. Have a nice day.